Okay students, now we will move to the problems on lenses. Okay, we have seen the problems on mirrors, that is concave and convex mirrors. Now in the refraction, since we have the Snell's law, then refractive index, and we have lenses and related formulas. So we have to see the numericals. First we shall solve the numericals on lenses, and then we will come to the refraction and the refractive index and the Snell's law. Okay. Now, what are the important formulas that has to be remembered to solve the problems on lenses? You can see here. The first is the lens formula, right? That is 1 by f is equal to 1 by v minus 1 by u. So for the problems, we have to use the modified lens formula, just how I have simplified. You know that f is equal to uv by u minus v, that is product by difference. In mirror it was product by sum. Here, in order to find the focal length, it is product by difference, means uv by u minus v. Then you have the relationship between power of the lens and the focal length, that is p is equal to 1 by f, or f is equal to 1 by p. The unit of power of the lens is in diopter. Now, in the problems, usually the focal length will always be in centimeters. We will not have the convex lens which has a focal length in meters. Okay, even though if it is given in meters, you have to convert to centimeters. So for that, you have to multiply 100, because 1 meter is equal to 100 centimeter. Therefore, P is equal to 100 by F. Okay, when your focal length is in centimeters. Now, unit of power of the lens is diopter. Okay. Now, for the magnification, we have the formula M is equal to H1. M is equal to H2 by H1, which is equal to V by U. Okay. Then power of the lens is equal to the power of the combination of the lenses. That means you have two or more lenses. Okay, which is in combination, which is in close contact with each other. Then the whole combination, that is the total power of the lenses, which is equal to the algebraic sum of the individual powers of the lenses, that is P is equal to P1 plus P2 plus P3 plus so on to Pn. So you have to remember all these formulas. Okay. Okay, now moving on to the first problem. Just listen to the first problem on lenses. A student has to project 3 times magnified image of a candle flame on a wall. Name the type of the lens, that is converging or diverging, required for the purpose. If the candle flame is at a distance of 6 meters from the wall, find the focal length of the lens. Now carefully see and understand the problem here. The student has to project 3 times magnified image of a candle. Now see here, when you are getting 3 times magnified image of a candle, means you have an image of a candle. This image of the candle is image of this candle, and this candle's image has to be projected thrice, which means magnified image. When you are getting the magnified image, when it is in convex lens on a wall means screen. Okay, name the type of the lens, that is whether it is converging or diverging. You know that convex lens is converging lens, right? If the candle flame is at a distance of 6 meters from the wall, find the focal length of the lens. Now, the student has to project this image of this candle, okay? Magnified image, right? Means the image should be magnified thrice. This is the object. Its image should be thrice the magnified. Means magnification is given. That is, M is given. M is given. That since it is. Since that M is in which lens it is? M is for convex lens. That is, the magnification factor will come negative. That is, what you will get? -3 you will get, right? Why? Because for convex lens magnification, because m is equal to h2 by h1. So h1 is positive, h2 is negative. So magnification factor will come negative. So it is 3 times the magnified image of a candle on a wall. Now if the candle flame is at a distance of 6 meters from the wall, okay, now find the focal length of the lens. You have to find out focal length of the lens. Then if the candle flame is at a distance of 6 meters from the wall, so how we have to look? From the wall. Now see here, this is the principal axis. Okay, now here is the lens. Now here is the candle flame. Okay, now here is the candle. Okay. Now this is the object candle. Okay. Now the image is 3 times, right? Now see here, this is the image. You are getting three times. Okay. Now this is the object. Now this is the wall. Okay. Now this is the wall, and you are getting the image. Okay. Now you are getting the image of the candle, which is 3 times of the object. That 3 times is nothing but what? M is equal to -3. You have to take. Okay. Why? Because always the downward height in the formula h2 by h1, this will be negative and this will be positive. So negative by positive results in negative. Now I have to find out the focal length. Okay, focal length is this distance you have to find out. Right? At what this focal distance you are getting the image. Then what you have to find out? So, and if the candle flame is at a distance of 6 meters from the wall, this candle flame, now this object is nothing but what? This is candle flame. This is candle flame. Now, this from the wall, it is at a distance of 6 meters. Okay, it is at a distance of 6 meters from the wall. Now, this is the wall is nothing but screen on which you are getting the thrice the magnified image. Okay, that is of the object. 3 times magnification you are getting on the wall. Now from this wall where the image is caught, from there to the object it is 6 meters. They have not mentioned from lens. Okay, they have mentioned that the original candle flame, that is the object, is at a distance of 6 meters from the wall where the image is caught. Now you have to find out the focal length. Now you see here. Now here, in order to here what you are getting from the lens to the object, which distance you are getting? Object distance. Similarly from lens to the image, you are getting which distance? Image distance. From the lens to the object you are getting object distance. From the lens to the image you are getting image distance. Don't worry about the sign conventions now only. Okay. First you have to do the observation and you have to take the relevance, and then you have to go for the sign conventions. Now see here. Now magnification is given. Okay. Now we know that the magnification m, magnification factor m is given by h2 by h1, or it is also given by v by u. Okay, it is given by v by u. Or don't take negative sign, take only magnification. Magnification is 3 times. Okay, don't take negative sign. Okay, why? Because negative sign indicates only whether the object is at upper height or the above the principal axis or below the principal axis, or whether it is taken towards the left or towards the right. That is the indication of negative sign, but that the magnitude will remain the same. Okay. Now this m in place I will write this 3. 3 is equal to v by u, or cross multiplied v is equal to 3 times u you will get. Okay. Now after this, the distance of this image from the object, it is 6 meters. The 6 meter means what? From the lens to the object is u. From the lens to the image, that is wall, is v. If you add u plus v, you are getting 6 meters. Right? Therefore, u plus v is equal to 6 meters. Now, you know that v is equal to 3 times u. Right? In place of v, in place of we write 3u, okay, u plus 3u is equal to 6. 3 plus 1 is 4u is equal to 6, or u is equal to 6 by 4. 2 2s are 4, 2 3s are 2 1s are 2, 2 5s are. U is equal to 1.5 meters. Then you also know that you can find out V now. V is equal to 3 times U. 3U, which is equal to 3 into U is 1.5. V is equal to 4.5 meters. Okay. Now U is 1.5 meters. U is 1.5 meters. V is 4.5 meters. Okay, now you got this distance U is 1.5 meters and this distance, that is the image distance, is 4.5 meters. Object distance is 1.5 meters, image distance is 4.5 meters. Now you have to consider the sign. What sign? Now see here. When the object, you are measuring the distance from the lens moving left, okay, against the incident right from the optic center, the distance is taken as negative. So you will get negative. U is equal to minus 1.5 centimeter. Now V is towards the right side. That is the image distance from the optic center of the lens. You are moving in the direction of the incident light, so it taken as positive. So V is equal to plus 4.5 meters. Now when you know U and V, you can easily find out the focal length, right? What is the formula for the focal length? You know that. The formula for the focal length F is equal to UV divided by U minus V. Now U is minus 1.5 into V is 4.5 divided by U. Minus 1.5, then minus V means minus of plus is minus 4.5. So what you will get focal length? So you will get it as you can multiply this 1.5 into 4.5. So what you will get? 6.75 divided by, so what you will get? Minus 6. Minus 6.75 by minus 4, minus 1.5 minus 4.5 is minus 6. If you simplify that, you will get F is equal to 1.125 meters. What you will get the focal length? Focal length you got it as 1.125 meter. Now see here, minus divided by minus is plus. You will get focal length plus, which means you know that before I wrote the diagram, right? In the diagram, where was the image? Towards the right side. Towards the right side measurements means the distances will come positive, whether it is image distance or focal length. So that's why focal length is plus 1.125 meters. Okay students, let us move to the second problem. Just carefully listen to the problem. Draw a labeled diagram for the formation of image by a convex lens. So lens, they have given convex lens of focal length 15 centimeters. Now for convex lens, where the image is formed? Towards the right side. So focal length is positive. So plus 1.5 centimeter. So draw a label diagram for the formation of image by a convex lens of the focal length. Sorry, not 1.5, 15. Okay, 15 centimeter. When the object is placed at a distance of 25 centimeter from the lens, object distance is U. It is placed at a distance of 25 centimeter from the lens means from the lens object is always placed towards the left. So what you have to take? You have to take with a negative sign, minus 25 centimeters from the lens. Determine the size of the image. Determine the size of the image formed. If the size of the object is 4 centimeter. Size of the object means object is always above the principal axis. So that's why plus 4 centimeter. You have to find the size of the image. Now, in the problem they have also asked you to trace the diagram. You can draw the diagram later. Why? Because you have to take the measurements and draw the diagrams, right? So that's why in order to draw the right diagram, do it at last. First find out the value of, you have to find out the value of V also, right? U is given, you have to find out the value of V and you have to find out the value of H2. Okay. Now you can see here, value of U is given, value of F is given, you can easily find out the value of V. So use the modified length formula. What is the modified length formula? So we have, what is that? F is equal to product by difference. UV by U minus V, or F is equal to, what is U? Minus 25 into, what is, we don't know V and we know F. F is how much? 15 divided by U, that is minus 25 minus V. Now cross multiply it, 15 into minus 25 minus V is equal to minus 25 V. Now minus, plus into minus is minus, 15 into 25, then you will get minus 15 V is equal to minus 25 V. Bring this to the left hand side, take this to the right hand side. So what you will get? 25V minus 15V is equal to, what you will get? Plus 15 into 25. Okay. Now, what you will get? 25 minus 15 is what? 10V, right? Is equal to 15 into 25, or V is equal to 15 into 25 by 10. Now, 2s are 5s are. Then, what you will get? Then V is equal to, how much you will get? Thirty-seven point five centimeters. 37.5 centimeter with the positive sign. Why? You know that since in the problem only they have mentioned convex lens, object is always towards the left side of the convex lens. Object is always towards the left side and image is always towards the right side. Towards the right side means we have to take the measurement of the distance moving along the incident line. So that's why image is plus 37.5 centimeters. Now you got the image distance. Now you have to find out what? You have to find out the value of H2. You know that H2 by H1 is equal to V by U. What is H2 we don't know. Then what is H1? H1 is given, that is 4 is equal to V is 37.5 by, next U is minus 25. Now cross multiply, minus 25 H2 is equal to 4 into 37.5, or H2 is equal to, bring this minus sign to the left right hand side, you will get minus 4 into 37.5 divided by this 25 will come to the denominator. Okay. Now this minus sign have shifted to numerator, means I have shifted here. Then if you simplify, you will get H2 is equal to minus of, you will get 6 centimeters. So this is the value of H2 is equal to minus 6 centimeter, which means to say that height of the image is negative, means height of the image is formed below the principal axis towards the right side of the convex lens. Now you got the image height, you got the object height, you got the object distance, now you got the image distance. Now you can only draw the ray diagram of the convex lens. Okay, now this is the problem. Okay, solution. Okay, now let us move to the third problem. A 2 centimeter tall object, okay, means the object, size of the object, that is 2 centimeter, placed perpendicular to the principal axis. Perpendicular means it is above the principal axis of convex lens. Okay, they have mentioned the convex lens. Means for convex lens, you should clearly get the ray diagram. Object is towards the left side, image is towards the right side. Okay, now that object size is given. That is 2 centimeter tall, h1. Okay, of focal length 10 centimeter. Now focal length means focal length is the distance at which the image is formed, right? Now that focal length is plus 10 centimeter. Means focal length is positive, means we are moving, taking the measurements towards right side of the lens. Okay, so of focal length 10 centimeter. Now an object is how much? That is h1 is equal to plus 2 centimeter. Why the object height is plus 2? Plus indicates it is above the principal axis, upward measurement. Then focal length is given, that is plus 10 centimeter. The distance of the object from the lens, means object distance is given, that is u, is 15 centimeter. How we have to take the object distance? Against the incident light. Against means minus, right? Minus 15 centimeter. Find the nature, position and size of the image. Size of the image means h2 you have to find out. Position of the image means v you have to find out. And nature of the image. Nature of the image. You have to find out. Now we have f and we have u. We can easily find out v. Therefore use the formula. F is equal to product by difference. uv by u minus v. Or f is 10 is equal to, u, that is minus 15 into v divided by minus 15 minus v, cross multiply it. So what you will get? 10 into minus 15 minus v is equal to minus 15v, or you will get minus 150 minus 10v is equal to minus 15v. Then what you will get? So bring this minus 15v towards the left hand side and move this 150 towards the right hand side. So what you will get? 15v, then minus 10v is equal to 150, or 15 minus 10 is 5v is equal to 150, or v is equal to 150 divided by 5, 5 ones are 5 threes are 15. What you will get? V is equal to plus 30 centimeter. So plus 30 centimeter indicates that the image distance, or the distance of the image which is formed is towards the right side of the lens. That's why when you are taking the measurement along the incident ray direction, that's why it has come positive. That is also indication, you should get positive. Now you got the position of the image, that is image distance. Now you have to find out what? h2, right? So we have the ratio of the magnification, right? We know that h2 by h1 is equal to v by u. So we have to find out h2 divided by, we know h1, that is 2 plus 2, or 2 is equal to v is 30 divided by u is minus 15. Here only you can have the simplification, 1s are, 2s are. So shift this minus sign to the numerator, you will get h2 is equal to cross multiply 2 into minus 2, or h2 is equal to minus 4 centimeter, which means height of the object, height of the image is minus 4 centimeter. Minus sign indicates that the image is formed below the principal axis. So what is the nature of the image? Here only you are getting the clue in the question, because they have mentioned it as convex lens. Therefore, nature of the image is what? Real and inverted. Nature of the image is real and inverted. Also you can see here, object height is plus 2, means 2 centimeter above the principal axis. Image height is 4 centimeter below the principal axis. Which is more? Height of the image is more than the height of the object, which means the image is large, magnified. Okay. Now students, let us move to the fourth problem. Now see here, a concave lens. Okay, you have understood. The lens is given as concave lens. So where is the image and where is the object? Okay, because we have only two cases. now only you should get the ray diagram or that is virtual and direct, right? Now a concave lens has focal length of 15 centimeter. So concave length has the focal length of 15 centimeter means what you have to take, the focal length is towards left side. Why? Because both object and image is formed on the left side itself, right? That is towards the virtual side. So you get focal length is equal to minus 15 centimeter. At what distance should an object from the lens be placed? At what distance should an object from the lens be placed? Means you have to find out u. At what distance should an object from the lens be placed so that it forms an image at 10 centimeter from the lens? So that image is given, that is 10 centimeter from the lens. Image is also towards the left side only, that is given, okay, from the lens. Also find the magnification of the lens. You have to find out magnification also. This is the problem. Now you have focal length, you have the image distance, and you need to find the object distance. Now it is concave lens. So whatever it may be, use the same mirror formula. Therefore, F is equal to product by difference. UV by U minus V. F is equal to, you don't know U, but you know V, that is minus 10, and F is also given, that is minus 15 divided by U minus V, minus of minus 10. Okay. Now if you can cross multiply minus 15 into U, minus into minus is plus. So U plus 10 is equal to, plus into minus is minus, U into 10 is 10U, minus 10U. Okay. Now multiply 15 to the terms which are in the bracket, that is what you will get, minus 15U, then minus 15 tens are 150 is equal to minus 10U. Bring this minus 10U to this side and take that 150 to the right hand side. So what you will get, minus 15U plus 10U is equal to what you will get, plus 150. Okay. Now minus 15 plus 10 is what? Minus 5U is equal to 150, or U is equal to 150 by minus 5. 5 ones are, 5 threes are 15. So minus taken to the numerator means U is equal to minus 30 centimeter. See here, where is the object situated? It is situated at minus 30 centimeter means negative sign indicates that you should move towards the left. But 30 indicates what? 30 indicates that it is at 30 centimeter from the lens. See the object, the image, 10 centimeter. So image is what? The image is coming first, and next is the object, which means both are coming towards the virtual side or towards the left side. So that's why it is a concave lens. This is also indication that the given lens is concave lens. From the numericals also you can find out using these signs. Next you have to find out what? The magnification, right? So magnification M is equal to, they have not given the size of the object and size of the image, so that's why we have to take image distance by object distance. That is, we know that M is equal to V by U, or M is equal to V is minus 10 divided by U is minus 30. Minus divided by minus is plus, so what you will get? M is equal to plus 1 by 3. So this is the you can even simplify and keep it in decimal also. So the magnification factor is equal to plus 1 by 3. Now moving to the fifth problem. I'll just read out the problem. Rohit focused the image of a candle flame on a white screen using convex lens. So they have mentioned convex lens. He noted the position of the candle is equal to 26 centimeter. Position of the convex lens is at 50 centimeter and position of the screen is equal to 74 centimeter. First, what is the focal length of the convex lens? Second, where will the image be formed if he shifts the candle towards the lens at a position of 38 centimeter? Draw a ray diagram to show the formation of the image. Now, once you find out the solutions or the values of 1 and 2, to draw the ray diagram, it's very easy. Why? Because you have already found out that they have given that Rohit is using convex lens and what type of image he is getting. Before that, carefully observe here. You need to see and observe the problem and draw some rough diagram for it. Okay. Now, Rohit actually did some experiment. Okay. He has this candle flame and he took the convex lens. That candle flame is the object. Now, he noted the position of the candle. Position of the candle means what? Position of the object. Now, see here. Now, this Rohit, this is Rohit. Now, this is a line. Okay. Now, what he did at this position is 0. Now, what he did, he noted the position of the candle. Now, from here, he is moving from left to right. The position of the candle is at 26th centimeter. Now here you have the candle. Okay. Now here you have the candle. Now the position of the convex lens is 50 centimeter. Again from here, okay, that is from 0, 50 centimeter will come around here. Okay. At this point, there is position of convex lens. Okay, now we can have this convex lens here. Now, and the position of the screen as observed by Rohit, it is at 74 centimeter. Again moving from the same 0 here, it is at 74 centimeter around here. Okay, now here you have at 74 centimeter, here you have screen. What do you mean by screen? Screen is the place where you are getting the image of the candle flame, and this is the object. But in reality, how you will measure the object distance and image distance? This is the object distance from the lens, right? That is u. That is, you have to take minus u. Why? Because you are measuring against the incident light. And the image you are getting towards the right, that is on the screen you are getting the image, and this is the image distance. And it is always positive. Why? Because towards the right side, if you are taking the measurements along the incident line. Now, what is the value of u? What is the value of v? In order to find the value of u, again start from here. From 0 to lens, it is 50 centimeter. Okay, it is 50 centimeter from here to here. Now, from the same 0 to object, it is 26 centimeter. So, 50 minus 26. Okay, will you give you the u? That is, this distance minus this distance will give you the object distance. Similarly, from 0 to 74 minus 0 to 50, which means you will get the image distance. Okay, if you are subtracting 74 minus 50. Okay, this is 50 and this is 74. 74 minus 50 will give you the image distance. So you should have this diagram in your mind, or you have to do roughly and then you have to proceed with the problem. Okay, so now what you have, the object distance, how you have to find out, that is u is equal to minus of 50 minus 26. Okay, then image distance is plus 74 minus position on 50. Okay, so what do you get? Minus 24 centimeter is the object distance. Image distance will be plus 24 centimeter, because 74 minus 50, 4 minus 0, 4, 7 minus 5 is 2. So plus 24 centimeter. Now what do you have to find out? The first one. What is the focal length of the convex lens? Easily you can find out focal length. F is equal to product by difference. UV by U minus V. F is equal to, then U is minus 24 into 24 divided by minus 24 minus of plus 24. Or what you get? F is equal to minus 24 into 24 divided by minus 24 minus 24 is what? Minus 48. So 1s are 2s are. right? Then 2 ones are 2 12s are. So minus divided by minus is plus. So focal length is plus 12 centimeter. This indicates that the focal length is positive, means the image is formed towards the right side. Okay. Now after finding out the focal length, see the second. Now this we have found out. Where will the image be formed? If he shifts the candle towards the lens at a position of 38 centimeter. Now he is shifting the candle from 26 to 38. From 26 to 38 means he is shifting, which means if he is shifting the candle means object is shifting from 26 to 38 means there has to be the change in the object distance. Therefore, for second problem we have to find out u. So u again with the sign conventions negative, the lens is at a distance of 50 minus now the new the shift that he has made in what it is 38 centimeter, right? Now from 26 to 38 he is shifting. So 50 minus 38 you have to find out. Then u is equal to what? What you will get? Minus 12 centimeter. So what you will get is u is minus 12 centimeter. Now for this shift, okay, for this new distance, that is new object distance, you have to find out what is the image distance. Again use the same formula. Okay, f is equal to product by difference. So f is focal length we have found out, 12 is equal to, then u is how much? Minus 12 into, you have to find out v divided by minus 12 minus v, then cross multiply 12 into minus 12 minus v is equal to minus 12v. Then what you will get? If you want, you can simplify or minus 144, 12 12s are okay. Then minus 12v is equal to minus 12v. Then what you will get? Now this minus 144 minus 12v plus 12v you will get. Now what you have to do is, for minus 144 this is equal to 0 here, or else you can shift this. Minus 12v plus 12v is equal to plus 144. Now minus 12 plus 12 will give you what? Will give you the 0 value. Okay. Now here image value is getting 0 means it is not so. Here image value is nothing but it is formed at infinity. It is formed at infinity. Why? Because anywhere if the object is placed, whether it is at 26 centimeter or whether it is at 36 centimeter, obviously you have to get the image. But that image here, it is the v value here it is getting cancelled. Okay, and it is coming 0 means image is not 0. Why? Because at somewhere image has to be formed, but it is at a very far distance. What is that very far distance? Image is formed at infinity. Now we have solved out the second case. Now draw a ray diagram to show the formation of the image. You have to draw the ray diagram to show the formation of the image. That is, image is formed at infinity for the object which is placed at a distance of 38 centimeter. Take the scale and take proper measurements and you can draw the ray diagram. Thank you. Okay, now moving on to the sixth problem. I just read out the problem. If the image formed by the lens for all the positions of the object placed in front of it is always erect and diminished, what is the nature of the lens? Draw a ray diagram to justify your answer. If the numerical value of the power of this lens is 10 diopter, that is 10d, what is the focal length in Cartesian system? Now, in the given problem, they have not mentioned what is the lens, but they have given the hint that for all the positions of the lens, the image is coming erect and diminished. Which type of lens? Concave lens. You have to draw the ray diagram of concave lens, the second ray diagram. Okay, that is what? When the object is placed. Okay, the image what you are getting on the same side of the object, but it is diminished. Okay, so that image or that ray diagram we have to draw for this. Okay, now you can draw this ray diagram. Now it is always erect and diminished. If the numerical value of the power of the lens, now what you have to find out, numerical value of the power of the lens is given, that is P is given as 10 diopter. What is the focal length in Cartesian system? Now you have the formula P is equal to 1 by F. You cannot take 1 by F. Why? Because P is equal to 1 by F comes into picture when the focal length is in meters. Now for whatever practically the lens what we are using in the laboratory or for the problem sake, the focal length will not be in 1 meter, it will always be in centimeter. So what we have to use the formula? Therefore power is equal to 100 by F. Okay, why? Because 1 meter is equal to 100 centimeter. Using this formula, find the value of focal length. Now P is having 10 is equal to 100 by F, or F is equal to what? 100 by 10. So what you will get? Focal length is equal to 10 centimeter. Focal length is equal to 10 centimeter. So in Cartesian system, the focal length value is 10 centimeter. Now we have to be very careful about the sign also. Why? Because in concave mirror, since both the object and the image are formed towards the left side, the distance what we are considering is negative. So we have to write negative sign, that is minus 10 centimeter. Thank you. Okay. Move to the 7th problem. Just carefully listen to the problem. We wish to obtain an equal size inverted image. Equal size inverted image. Think of the ray diagram on which lens it is. Of the candle flame. Candle flame is the object. We wish to obtain the equal size inverted image of a candle flame on a screen kept at a distance of 4 meter from the candle flame. Name the type of the lens used. What should be the focal length of the lens and at what distance from the candle flame should the lens be placed? Draw a labeled diagram to show the image formation. Now you got the hint. Okay, now here you have the lens. Now at 2f1 and here it is 2f2, right? Now here you have the object. And here you have the image, same size. Okay, that is AB is the object, then A dash, B dash is the, both are same size. Okay, now here you also know that the object distance and the image distance they are also same. Why? Because they are placed at same positions. This is placed at 2f1 and the image formation is real and inverted at 2f2. The lens used is convex lens. Now you can see here, from the lens, the object is at a distance of u, and from the lens, the image is formed at a distance of v. Both are same distance, means u is equal to v here. But see here, we wish to obtain equal size inverted image of a candle flame on a screen kept at a distance of 4 meter from the candle flame. Means this is the candle flame. Okay, now this is the screen. From the candle flame to the screen, is 4 meter. Okay, from object to the image is 4 meter, which means u plus v is equal to 4 meter now. Okay, what is given here? Now the name of the lens means it is convex lens. Now see, for the C part, draw the labeled diagram to show the image formation. You can draw the ray diagram, you can draw. Okay, now it is convex lens. Now as per the ray diagram, you have u plus v is equal to 4 meters. Okay, then you know that u is equal to v in this case, right? But u is equal to v. Therefore, substitute in place of v, substitute u. So u plus u is equal to 4. 2u is equal to 4, or u is equal to 4 by 2. U is equal to 2 centimeter. If u is equal to 2 centimeter means therefore v is equal to 2 centimeter. Now carefully observe the signs. U is measured towards the left, so negative sign. Okay, U is equal to minus 2 centimeter, V is equal to plus 2 centimeter. Now we got the values of U and V. You can find out the value of focal length. Okay, what is the value of focal length? That is the formula for focal length, product by difference. F is equal to U is minus 2 into plus 2 divided by minus 2, then minus of plus 2. So what you will get? Minus 4 divided by minus into plus is minus 4. Okay, so cancels, minus divided by minus is plus, focal length is plus 1 meters. Okay, at 1 meter. This is the value of the focal length, that is plus 1 meters. Thank you. Now 8th problem. The image of the needle placed 10 centimeter from the lens is formed on a wall 20 centimeter on other side of the lens. Find the focal length of the lens and size of the image formed if the size of the object needle is 2.5 centimeter. Now there is a needle, okay, there is a needle and here is a lens. Now which type of lens? Obviously convex lens. Why? Because formed on other side. Here other side, that is the clue. Other side means towards the right side. Towards the right side means which type of lens? Convex lens only. Now there is a needle here. It is placed at 10 centimeter from the lens. Okay, it is at 10 centimeter from the lens. Now formed on a wall 20 centimeter on other side. On other side it is at 20 centimeter. This needle is, the image is at, now it is at 20 centimeter. Which means, okay, here it is at 20 centimeter. Okay, from the lens. Find the focal length of the lens. So what is the focal length of the lens? Then, and the size of the image formed. Size of the image formed means H2 you have to find out. If the size of the object needle is 2.5 centimeter, means H1 is given how much? 2.5 centimeter. Now we got the analysis of the problem. So this is the analysis of the problem. So I will write the data once again. You can draw the this ray diagram if you want roughly towards the right side of your book. Okay, because if you draw roughly the diagram, you will understand the concept well. You can be able to relate the description of the problem to the diagram. Okay, that is the beauty of physics. In the physics means just you have not reading the problem and taking the data, using the formula and finding out the answer. No, that is not so. Analyze the problem, read the problem, think of the problem, imagine yourself. Okay, which is the lens, where is the object, where is the image, what is the object distance, what is the image distance. Then write the data, visualize the problem. Okay, that's what physics is all about. Now, you have the image of the needle placed 10 centimeter from the lens is formed on a wall 20 centimeter, means here U is given, that is minus 10 centimeter, then V is given plus 20 centimeter. Find the focal length of the lens you have to find out. Then you have to find out H2 also. Then H1 is given, that is plus 2.5 centimeter. Why? Because H1 means height of the object is always above the principal axis as per the new Cartesian sign conventions. Now you have U and V, you can easily find out F. Therefore F is equal to product by difference. UV by U minus V. Therefore F is equal to U is minus 10 into V is plus 20 divided by again minus 10 minus 20, because minus of plus 20 is minus 20. So what you will get? F is equal to minus 200 divided by minus 30, right? So what you will get? F is equal to minus divided by minus is plus, 3 6 are 18, then 6.66, you will get the recurring value, that is 6.66 centimeter is the answer. Okay, now or 6.67, it is mentioned in the textbook, or 6.66. Now focal length is, you have got the positive value. Why? Because you are getting the measurement of focal length only at the image side, right? That's why the image is always formed towards right side. That's why positive side. Now Not only that, you have to find out the height of the image. Now use the ratio formula, that is, you know that h2 by h1 is equal to v by u. Now we have to find out h2 divided by h1 is given, that is 2.5 is equal to, now v is given, that is 20 divided by u is given, that is minus 10. 10 ones are 10 twos are 20, or h2 is equal to, cross multiply with the negative sign going upwards, it is minus 2 into 2.5. h2 is equal to what? Minus into plus is minus, you will get 5. Okay, minus 5 centimeter. Minus 5 centimeter is the height of the image, which means height of the object is plus 2.5. Height of the image is minus 5. Forgetting the signs. Which is greater here? h2 is, that is height of the image is greater than height of the object. So height of the image, what you are getting is minus 5 centimeters. Thank you. Moving to the ninth problem. An object is placed at a distance of 30 centimeter, 30 centimeter from a concave lens, of focal length 15 centimeter. Find the nature and position of the image. Very simple problem. They have mentioned concave lens. So get the ray diagram of the concave lens and be ready with the sign conventions. Okay. Now, object distance, that is u. It is always minus, that is 30 centimeter. From a concave lens of focal length. Focal length. When you speak of focal length, you should get the image of the, you should get the position of the image also. Position of the image is towards left side only in the concave lens in both the cases. So focal length will also be negative. Okay, is minus 15 centimeter. Find the nature of and position of the image. Means you have to find out v and nature of the image. Nature of the image. Now use the lens formula. That is f is equal to product by difference uv by u minus v. Then f is minus 15 is equal to u is given minus 30v divided by u, that is minus 30 minus v. Cross multiply it. So what you will get? Minus 15 into minus 30 minus v is equal to minus 30v, or what you will get? Minus 15 3 is 45, right? So minus 450, then minus into minus is plus 15v is equal to minus 30v. So bring this minus 30v to the left hand side, move that 450 minus 450 to the right hand side. So what you will get? 30v plus 15v is equal to 450. So focal length is minus 15. So uv by u minus v, minus 30 into v divided by minus 15 into minus v. This is plus 450. Sorry, this is plus 450. Why? Because minus into minus is plus. Now what you will get? You will get minus 450, right? When you go to the that side. So plus 30 plus 15, what you will get? 45, right? 30 plus 15 is 45, v is equal to minus 450, or v is equal to minus 450 divided by 45. So 1s are 10s are. So image distance is minus 10 centimeter. Okay, image distance is minus 10 centimeter. See the object distance. Object is at minus 30 centimeter. Image is at minus 10 centimeter. Means height of the image is less than the height of the object. So remember which ray diagram? Second ray diagram of the concave lens, right? So both are towards left side. What is the nature of the image? Nature of the image is virtual, erect and magnified. Virtual, erect and magnified. You can see. Okay. Sorry, not magnified. Sorry. Virtual, erect and diminished. Or lesser the size of the object. Because object is 30 and image is minus 10. So it is diminished. Thank you. Let's move to the 10th problem. Find the focal length and nature of the lens. Nature of the lens which should be placed in contact with the lens. Which should be placed in contact with the lens of focal length 10 centimeter, so that the power of the combination becomes 5 diopter. See, think. Now we have two lenses, okay? See here, we have to find the focal length nature of the lens, first lens. Now this is lens 1 and this is lens 2. And we don't know what is lens 1, whether it is concave or convex, we don't know. We have to find out. But see the lens 2. Which should be placed in contact with the lens, one more lens of focal length is given 10 centimeter, which means positive sign. When the focal length of a particular lens is having the positive sign, which type of lens? It is a convex lens, okay. Now this is, when the focal length becomes positive means it is convex lens, okay. Now you have to find out what is this lens, okay. Now, so that the power of the combination becomes 5 diopter. When you combine these two lenses, the power, that is the combination, power of the combination, total power, it is equal to 5 diopter. Means this lens plus this lens is equal to 5 diopter. We don't know what is this first lens, okay. But here the focal length of the second lens, that is the convex lens is given, that is f2, focal length of the second lens is given. How much it is? 10 centimeter. You don't know what is the focal length of the first lens, as well as you have to find out what is that lens, okay, which lens is that, whether it is concave or convex also you have to find out. Now how we have to do this problem? First you have to write the combination of the power of the lens, that is that formula I have to write, lens power combination, that is PT is equal to, total power is equal to, how many lens? There are two lens, so two powers. P1 plus P2. Now express the powers in terms of focal length. That too in centimeters. They have given in centimeter. You know how to write. So PT is equal to P1, that is 100 by F1. This is this lens. We don't know what is F1. Plus P2 is again 100 divided by F2. Now PT is equal to 100 by F1, 100 by F1 plus 100 divided by F2 is given. F2 is how much? 10. Now here you can simplify. Okay. Now what you get? PT is given. That is PT. Power of the lens is 5 diopter. So 5D or 5 diopter is equal to 100 by F1 plus 10 by 1 means 10. Now take the LCM here on the RHS. LCM is F1 only. So what you will get? 5 is equal to 100 plus 10 into F1 divided by F1. Now cross multiply it. What you get? 5 F1 is equal to 100 plus 10 into F1. Now bring this 5 F1 to the right hand side. Take this 100 to the left hand side. So what you will get? 10 F1 minus 5 F1 is equal to minus 100. Okay, now 10 minus 5 is 5. So 5 F1 is equal to minus 100, or F1 is equal to minus 100 by 5. 5 1s are 5 20s are. F1 is equal to minus 20 centimeter. Now what this indicates? The value of F1 is negative, you are getting, that is minus 20 centimeter. So here the value of F1 is minus 20. The value of F1 is equal to minus 20 centimeter. Now what type of lens is this? When you are getting the focal length to be of negative value, it is obviously concave lens. It is concave lens. Okay. Now this is the solution to the problem. Thank you.